So you need to calculate a net present value, but you don't have one of these, a financial calculator. I'm going to show you how to calculate the net present value of a series of cash flows, and this is going to work on any calculator. So let me show you an example. Okay, here is a series of cash flows. It's a very short timeline. It's only 3 years long, and usually you got to spend money at time zero, and then it makes you money over time. Okay, so the way that we do this very quickly with the calculator is we actually start at the end of our timeline over here, okay? And what we're going to do is we're going to divide each of these cash flows by 1 dot the discount rate, or 0.10 as a decimal. And what we're going to do is we're going to go over here to the end of our timeline, this 180, and we're going to divide everything by 1.10. So this is going to be a division right over here. Okay, so when we do that, when you divide 180 by 1.1, it ends up becoming this number right here. I'm going to put it right over here, 163.64, just like that, okay? So we've now moved this cash flow, this 180, we've moved the 180, and we turned it into this number right here, the 163.64, okay? Now, right now we have two numbers that are essentially at the same point in time. Both the 160 and the 163.64 are under year 2. And when you have numbers under the same point in time, you can add them or net them together. So we're going to add them together like this, and let's see what we get. Okay, so we take that 163 plus another 160 gives you 323.64. Okay, so we're going to repeat the process that we did over here at the end of dividing by 1 plus the rate, but we're going to do that to this total and move that over here to year 1. So let's see how that would work. I would take this number right here, divide that by 1.10, and that's going to move us over here to year 1. So let's see, divide by 1.1, and you end up with 294.21. Okay. Again, we have two numbers that are at the same exact point in time, so we can add them together, and that's going to be 444.21, like this. And again, repeat the process where we grab that cash flow and move it back one period to the left by dividing by 1.10, and that's going to move you back again. But now we're at year 0, which is essentially the end of the problem. So let's do that next. Here we go. Just divide by 1.1. Whoops. I had 150 plus 294.21. There we go. And then divide by 1.1. And then we end up with 403.83. Okay. Again, we have two numbers at the same point in time. We're just going to add those guys together like so. And there's a grand finale to the problem, 153.82. That's going to give us the net present value of this whole thing. Right here is the answer. Net present value is 153.83. Now, that is indeed the fastest way to solve that particular problem, and it will work with any calculator. And once you get good at it, you can do it very fast. It's a very fast method. Let me show you how fast you can actually get it done. Let me switch over to my desktop here, and let's try it now. Like from the end of our timeline, we're going to work our way from the right to the left and get this answer right here, this 153.83, and we're going to do it super quick. Okay, so watch this. I go end of the timeline, so 180 divided by 1.1. There's the 163, add 160 divided by 1.1. There it is, add 150 divided by 1.1, and then we just subtract the 250. Bam, look how fast that was. That's faster than a lot of financial calculators. So that's what I wanted to show you there in this particular problem, but I do want to show you one more. I do want to show you one more problem where sometimes they give you the timeline and it just like, it doesn't end. They have a perpetuity. There's like a growth rate, okay? So let me show you that over here in this particular problem. So what's happening is in year 3 and onwards, the cash flows are going to grow by 4% forever until the end of time. So imagine that beyond year 3, okay, so imagine beyond year 3, we had an infinite series of cash flows here that are growing until the end of time, and we need to take that into account. So it's not really ending in year 3, it's going to continue on forever until the end of time. So what do? Well, the formula changes. Remember how in the previous problem, what we did in the previous problem was we divided by 1 plus the rate. See how we divided by 1 plus the rate? Well, now we're not going to do that. Instead, what we're going to do is divide by r minus g. That's the only difference. So what I'll do here is I'm going to divide by r, which is the same 10%, but we're going to subtract this 4, so minus 0.04, and you end up dividing this thing essentially by 6%, right? 0.06. So let's knock it out here, okay? So here we go. We got 180. We're going to take 180 divided by 0.06, which is that spread between the 0.10 and 0.04, and that comes out to be 3,000, okay? So that means we can put this number and move it over here as 3,000. Okay, same situation where we have two numbers that are at the same point in time, so we add them together and you end up with 3,160, 3,160. Now, once we're in this situation where we have this cash flow here, the net 3,160, and you got to move it back one period to the left, we now do the same thing that we did for the first problem. And so what I mean by that is now we switch back to dividing by 1 dot the required return or discount rate, and now we just repeat the same exact process from earlier. So take that number divided by 1.1, and we get this guy right here, which is 2,872.73. That's what happens when you divide by 1.1. Again, we have two numbers at the same point in time, so I'm going to add them together. Let's draw a line, add them together. So add 150 to that. That gives us 3,022.73, like this. And now we just have to do one more of these where you divide by 1 dot the discount rate, and that's going to move us over here to year 0, and then we can net that against the cost of the investment, which is 250, and you'll have your net present value. Okay, so here we go. Divide by 1.1, which is the 1 dot discount rate. That moves you back. That moves you back one period, so divide by 1.1, and we have the 2,747.93, and we're almost done. Just subtract your 250, or just combine that with this number right here. So minus the 250, and bam, what's the answer? The answer is 2,497.93. All right, well, that concludes the problem with the growing perpetuity, and I hope that helps, and now you know how to do a net present value even without a financial calculator. Thanks for watching.